AWS Application to Trace Description. Application tracing in AWS helps you understand how requests flow through your application, identify performance bottlenecks, and troubleshoot issues. It provides a detailed view of the execution path of each request, allowing you to see which services are involved, how long each operation takes, and where potential performance problems lie. Prerequisites AWS account X-ray enabled. Use cases identify bottlenecks, pinpoint slow components or functions within your application, allowing you to optimize performance. Track request flow. Visualize the complete path of a request as it traverses various services, helping you understand how your application is structured and how requests are handled. Troubleshoot issues. Analyze traces to identify the root cause of errors or performance degradations, providing insights into the flow of data and execution steps. Monitor application health. Track metrics like latency, errors, and throughput across different components, giving you a comprehensive view of your application's performance and stability. Steps. Instrument application code. Add X-ray SDKs to your application code to capture traces, segment requests, and annotate them with relevant information. Configure X-ray daemon. Install and configure the X-ray daemon on your EC2 instances or Lambda functions to collect and forward traces to the X-ray service. Analyze trace data. Use the X-ray console to view and analyze traces. Visualize request flow, identify bottlenecks, and troubleshoot issues, challenges and fixes. High sampling rate. High sampling rates can result in excessive data collection, impacting performance and potentially overloading the X-ray service. Reduce sampling rate. Adjust the sampling rate to a lower value, ensuring that you collect enough data for analysis while minimizing performance overhead. Limited visibility. If your application code is not fully instrumented, you may have limited visibility into the request flow and potential bottlenecks. Instrument more code. Instrument additional components or functions within your application to gain a more comprehensive view of the request flow. Data retention. X-ray has a default data retention period, and traces older than this period will be deleted. Increase data retention. Increase the data retention period to ensure that you have access to historical traces for analysis and troubleshooting. Integration issues. Integrating X-ray with various services or frameworks can present challenges, particularly if compatibility issues exist. Use compatible libraries. Use compatible X-ray SDKs and libraries for your chosen services or frameworks to ensure proper integration and trace propagation. Performance overhead. Adding tracing functionality can introduce performance overhead, especially if high sampling rates are used. Optimize sampling strategy. Adjust the sampling rate to balance the need for data collection with minimal performance impact. Use asynchronous tracing for time-sensitive operations. Use asynchronous tracing techniques to minimize the impact on request execution time. Optimize tracing logic. Reduce the amount of data captured by limiting the number of annotations and keeping trace segments short. Optimize trace data transmission. Ensure that trace data is efficiently transmitted to the X-ray service, minimizing network overhead. Cost considerations. X-ray usage can incur costs, especially when using high sampling rates or storing traces for extended periods. Monitor usage and costs. Regularly monitor your X-ray usage and costs to identify potential areas for optimization. Adjust sampling rate and data retention. Adjust the sampling rate and data retention period to balance the need for data with cost considerations.